Welcome to a lesson on how to use the power rule or power property of logarithms, which is log base b of m raised to the power of n equals n times log base b of m. On the left, notice how n is the exponent of the number part of the logarithm, and on the right, n is the coefficient of the logarithm. We will be using this property first to expand logarithms, and then to write logarithms with a coefficient of 1. For the first example, we're asked to expand the logarithm using the power rule or power property of logarithms. We're given log base 7 of x to the 5th, which can also be written as log base 7 of x to the 5th in parentheses. Now we know x to the 5th is equal to 5 factors of x, so we could expand this using the product property of logarithms shown here, which should give us a sum of 5 logarithms. However, we're specifically told to use the power rule or power property of logarithms. So referring back to the property, notice how the exponent n in this logarithm is equal to 5, which means log base 7 of x to the 5th is equal to 5 times log base 7 of x. And now the logarithm is expanded using the power property of logarithms. For number 2, we're given log base 2 of 81. Notice right now the number part of the log is not written using exponents, so we cannot apply the power property of logarithms in this form. So let's determine the prime factorization of 81, so we can write 81 in the form of m raised to the power of n. Well, 81 is equal to 9 times 9, so we could write 81 as 9 squared and apply the power property of logarithms. But instead, let's look at the prime factorization. 9 is equal to 3 times 3 here, as well as here. 81 is equal to 4 factors of 3, which means 81 is equal to 3 raised to the power of 4, or 3 to the 4th. So log base 2 of 81 equals log base 2 of 3 to the 4th. Now that the number part of the logarithm is written in exponential form, we can apply the power property of logarithms. Notice how the exponent n is equal to 4, which means log base 2 of 3 to the 4th is equal to 4 times log base 2 of 3. And now we'll use the property in the reverse order to write logarithms with a coefficient of 1. And this is important because notice how in order to apply the product property and quotient property of logarithms from the right side to the left side, the coefficient of the logarithms must be equal to 1. So for number 1, we're given 3 natural log x. So looking at the power property of logarithms, notice how the coefficient n is equal to 3, which means 3 natural log x equals natural log x raised to the power of 3, or x cubed. On the left, 3 is the coefficient. On the right, 3 is the exponent. And then for number 2, we're given 1/2 log base 3 of the quantity x minus 2. Here the coefficient is 1/2, which means 1/2 log 3 of the quantity x minus 2 is equal to log base 3 of the quantity x minus 2 raised to the 1/2 power. The logarithm does have a coefficient of 1 now, but having a quantity raised to the 1/2 power is the same as taking the square root, so we can also write this as log base 3 of the square root of the quantity x minus 2. These two logarithms are equivalent. One is written using a rational exponent, and one is written using a square root. I hope you found this helpful.